Thank you all for coming on one of the later speeches of the conference today. Super excited to have you all here. I'm Mary Coase. I am a product manager with Stackdriver Logging.
Hi, my name is Eduardo. I'm a software engineer at Treasure Data.
And we're here to talk to you today about getting started running a centralized logging solution on Google Cloud. And I have to say, nothing but my deep love of logs would convince me to stand up on stage here. So I'm really excited to get to share with you why centralized logs can make your life easier, how to do that in Google Cloud. Eduardo will talk a little bit about logging in Kubernetes specifically, and then some insights from managing logs at scale that we've learned sometimes the hard way through Google. So let me see just a show of hands. Do we have any current Google Cloud customers in the audience who use Stackdriver Logging? Awesome. And another show of hands, do we have any software engineers from Google here who use logging in their day-to-day life at Google? Yeah, they don't really let us into these. Oh, we have one, yay, couple. So they don't usually let us into these talks, so that's awesome. The team that I work with in Pittsburgh does both the logs to help all of our cloud customers manage their operations at scale, but also the logs that our Google engineers use for understanding the applications we develop internal to Google as well. So let's talk about why logs matter. Fundamentally, troubleshooting anything, but especially distributed microservices, is really hard. So we have in the cloud a bunch of interconnected pieces like this puzzle. And when something goes wrong, it's really hard to figure out how we need to put them back together. Logs will give us visibility into our system. So in the puzzle analogy, they're the picture on our puzzle pieces here. And while you could assemble things one puzzle piece at a time, a centralized log view will allow you to see all of the picture at the same time, which will help you to improve your reliability, performance, and security. So let's talk about how we actually deliver on a centralized logging solution running in Google Cloud. And I mentioned I am the product manager for Stackdriver Logging. That is one of 3 pillars that we have within Stackdriver. So we've got logging, monitoring, and application performance management, or APM. And each of these are part of a SaaS ops suite to help all of you monitor and troubleshoot your applications, whether they're running on GCP, AWS, or cloud-native infrastructure, and trying to keep your apps fast and available. So we have a bunch of different components here. We have log producers on the one side, and there are many different ways logs come in that you care about. So we have audit logs, which are super special. We've got platform logs that are sent from individual Google services, like Cloud Load Balancer. We have open source components that are creating logs that you might be running to power your infrastructure and your apps. And then there are logs that come directly from the apps themselves. On the other hand, we've got consumers of logs. So there are a number of different options for consuming logs. One, of course, is Stackdriver Logging. Some users will also want to consume logs in a tool like Google BigQuery, or save them for compliance in Google Cloud Storage, or use one of the many different partner applications that we support, including Sumo Logic, Splunk, and ElkStack, just to name a few of the more common ones. So and the log router is what actually glues these two things together, the producers and the consumers. So if I look over here, I've got at the top the log producers. Everything gets centralized through the logging API. And then we've got the log router, which will help us to get the logs to the right endpoint. And down at the bottom, we have the Stackdriver product on the left-hand side. And then on the right-hand side, we have other potential destinations, whether it's cloud storage, BigQuery, or anywhere else which can go through PubSub. In order to get logs into Stackdriver, there's zero setup for GCP audit logs and logs from GCP services, so any logs that are being created on your behalf by a GCP service. And then if you want to instrument your code, you can also use client libraries to send logs to the API directly. But the vast majority of our logs that aren't sent from cloud services actually go through our open source logging agent, Fluent Bit.
Hello. Maybe most of you already know what is a logging agent, but if we go like years ago, we will say that, and we can think about logging, the first thing that we can think about is maybe syslog. Have you used a syslog before? Please raise your hand. So everybody who raised their hand is over 30. Actually, yeah, so logging mechanisms exist for a couple of reasons. Maybe because you want to troubleshoot, you want to monitor something, or understand what's going on in your applications, in your system. So what we're talking about here, logging is not new. I think that logging exists from the beginning. Since if you're doing development, you're debugging, you have some kind of logging mechanism. If you're deploying your application, you have some logging mechanism for that. Could be through syslog, rsyslog, or just writing to a plain log file in the file system. But we have current problems now. In the past, we used to have like common messages. The application is doing A, B, C, D, or is crashing. We have some exceptions. But what happens when you have multiple applications that generate data in a different way? For example, if you know Apache Web Server creates their own log entry, saying this is an IP address, this is a protocol version, size of the document. If you look at, for example, MySQL logs, they look pretty much different. What kind of query was running? What's our reception? How are the tables? What, do we have some charting or things like that? So if you want to do logging, it's not because logging is cool. I think that honestly, logging is boring from a plain perspective. But you have to deal with that, right? Because you have problems that you need to solve. So the thing is, if you have multiple sources of information that come from different places in different formats, the optimal goal that you want to do is data analysis. So in order to do data analysis, you need a logging agent, and you need to have, this logging agent must have different strategies to deal with data formats, data sources. One thing is read log files from the file system. The other is listen from TCP or UDP. If you're using, for example, hardware devices like firewalls, and they are sending their logs over UDP, you need to support that too. So when moving forward, we can think about many logging agents. But the experience here is that Treasure Data, the company that I work for, we created Fluent Bit around 7 years ago to solve the whole data collection problem. And Fluent Bit, as an open source project, is fully open source under, right now, the CNCF, the Cloud Native Computing Foundation. The goal of this project is that allows you to consume logs from multiple places with different formats and ingest back the information on any kind of central database, like Google Stackdriver or your own Elasticsearch database or MySQL. In general, as a project and ecosystem, we have more than 700 plugins. And I think that from a company perspective, we maintain like 10 or 20, and all of the others are made by the community. Do you know Fluent Bit? Is anybody using Fluent Bit before here? Good, we have some users.
Awesome, thanks. So once we get logs into the centralized logging API, however that happens, and many times through our logging agent, our next goal is to get it to the right destination. And this is where the log router comes into place. So we have two kind of different flows for managing logs through the log router. One is called log syncs. And that is basically an inclusion filter. So you're going to say exactly what it is you want sent to these destinations. And if you don't say anything, nothing will go to these destinations. We can send the same log to BigQuery and PubSub or to none of the above. On the other side, we have logs being sent to Stackdriver, the logging product, and we manage this via exclusion filters. So if you do nothing, all your logs will go to Stackdriver logging. And then if there are certain logs that you don't want to go there, either because you don't want anyone in your company to have access to them, or if you don't want to pay for them, then you can use an exclusion filter to control what goes into Stackdriver logging. And that's a pretty big difference compared to many of the other cloud platform logging experiences out there. So I'll call out two important ideas around our log router. One is that logs can be exported to log syncs, even if they are excluded from Stackdriver log storage. So this is something that can be a little bit tricky to get from our documentation. We'll work on that, but hopefully clear now. And then the other thing that's a really powerful tool is a tool called aggregated exports. So most of our customers have an organization with more than one project. And they want to manage logs across their entire organization. A special use case here is security, where oftentimes the security team wants to see the audit logs across their entire organization. And so an aggregated export can be set up either at the folder level or at the org level, and it will inherit all of the stuff below it. So if audit logs are created for a new project that didn't exist now in the organization, we will go ahead and include those in the export as well. And then the last thing I'll talk about in terms of logging tools is how you analyze logs with Stackdriver. And we'll get to a demo here in just a moment, but Stackdriver logging supports both basic and advanced filters. We also have a tool called error reporting as part of the logging library toolkit here that will automatically go through your logs and group like logs together, specifically looking for stack traces and issues in your code. And then we also provide the ability to create alerts and dashboards from logs by using a tool called logs-based metrics. And that pairs with Stackdriver monitoring. So that's kind of a theme that you'll hear across the Stackdriver tools, is that while you can use logging by itself or monitoring by itself or our APM tools by themselves, if you use multiple ones together, you can actually get something that is more powerful than any of them individually. All right, and now my favorite part is demo time. If we could cut over here. Perfect. All right, so I have a web store running on GKE, and I can see the logs from my web store. At a first glance, I can see, hey, there are quite a bit of logs. Looks like a lot of errors, but I'm not really sure where to get started if there's an issue. So my first stop, and first stop for many customers, is let's check out error reporting to see if it's automatically identified anything for us. And sure enough, having looked through our logs, out of all of those errors, it's identified a specific error in our application that someone tried to set the quantity to less than 0, which caused a specific error. And I can click on that. I can see exactly how many customers have been impacted by this error. I can see the stack trace so that I can tell exactly where in my code this came from. And I could go to Stackdriver debugging to investigate further if I wanted to from here. I can also jump directly back to the logs to view the raw logs. I can link to an issue. So this one here links to a GitHub issue, for example. And I can also track the resolution status. So for example, if someone tells me, one of our developers says, hey, I fixed this error, should be all set, it's deployed, I can go ahead and say this error should be resolved. And then we say, okay, no known errors, that's great. If I go back to my catalog here, and we'll test it to see if this actually works, and I add something to my cart, Let's see what happens if we try to set the quantity to a negative number. We'll update the basket. And I'll come back over to error reporting and reload it here for just a moment. And this usually updates in about 5 to 10 seconds. And we can see that it automatically identified that the error had been seen again and reopened the issue. If I wanted to, I could also turn on notifications so that rather than me going to this dashboard, it'll proactively push alerts for new or reopened errors to my inbox. So that's a very common use case we hear from a lot of developers who are using Stackdriver logging. But we hear a number of other examples for like security use cases. So something that I hear a lot is I want to be alerted if anyone adds an email, let's say from a gmail.com domain. So I can, in the UI, I can interact with it in sort of a point and click mode, but I can also interact with the logs in the advanced filter and then type in more advanced queries. So in the case of identifying something that comes from a gmail.com account, I need to create a logs-based metric so that I can then alert on that. So I'm going to go over to my logs-based metrics, and I've created one here. I'm going to go ahead and edit that metric. For anything that comes from logs that are set IAM policy, that binds a member to @gmail.com. I want to count all of these, and that's kind of the first step. So I'll be able to have dashboards about everyone who's been added from an @gmail.com account, and then I can also create alerting policies on that. And I can see that earlier this morning, my Google account did add somebody who was @gmail.com. So let me go back to our logs-based metrics and go ahead and show you how you would create an alerting policy on this. So I'm going to create alert from metric. This will pop me over into Stackdriver monitoring, which is where I manage all of my dashboards and my alerting policies. So I'm able to here see the logs-based metric. Take a look here. I don't have any recent ones, but I'm going to go ahead and create an alerting policy if I ever see this, because I don't ever expect to see this. And instead of for duration, I'm going to say most recent value. So if this ever happens, I want to be alerted. Go ahead and save the condition and create a notification. So I'll send it to my favorite email address, auditlogsrock@gmail.com. I can add some documentation in terms of who to contact. Name this policy, and I'll go ahead and save it. So now if I go ahead and add a new member to an IAM policy anywhere in this project, I will receive a notification about this. All right. Another common use case we hear from customers is that they want to send their logs someplace else. So this is the beauty of the centralized logging solution, is that it all comes in centrally, and then we can slice and dice it and send it to many different places using exports, which is the log router that we were talking about just a moment ago. So I'll start out with a very common use case, which is I want to send all of my audit logs to BigQuery. So I select a filter. In this case, I'm going to say everything that matches the activity audit logs in the log name. And then I simply select BigQuery and the destination and create a sync. And any future logs that match this will automatically be sent to BigQuery, which is great. But that only helps me for this project. What if I want to do this at the organization level? So in this case, I need to pull up my Cloud Shell here. And I can use a gcloud command to set this at the organizational level. And I'll call out right here, we have include children, and we're setting this up at the organization level. Same thing though, the log name matches the filter of anything that has cloudaudit.googleapis.com. And I'm going to go ahead and save this. And now any audit logs from anywhere in my organization will all go to the same BigQuery destination. Now, one tricky thing just to remember is now that I set it up at the org level, any audit logs that come from this project will be written twice. So in that case, I'd probably want to go back and get rid of the one at the project level. Another thing that we have users do a lot is I want to act on logs. So in this case, let's say every time a new VM is spun up, I want to take a look at it, process it with Cloud Functions maybe, and add some labels or apply some rules to it. So I'm going to create a sink for any time that I have created an instance, which is the insert command. And I'll be able to send all of these to PubSub. I can then use a Cloud Function to pull all of the logs from PubSub, process them, take whatever action I want on them. So this is another common use case we see. All right, and then last but not least, we'll talk about log exclusions. So we have a page dedicated to helping you understand what your log volume is across your various Google Cloud resources or AWS resources here as well. And I can see, for example, taking a look here, a lot of my volume is coming from this, in this project is coming from Kubernetes. So that's the bulk of my logs. I can see, though, that projected through the end of the month is 43 gigabytes, which is well within the free limit of 50 gigabytes. So I'm not too worried. But I could go ahead and say, you know what, I'm going to send these logs maybe to my Elk stack. I don't want to pay for them in Stackdriver. I could go ahead and disable the logs altogether here, or I could create an exclusion filter based on this. And for example, say anything that is less than a warning level, I want to maybe just sample those logs. So instead of getting excluding 100% of them, maybe I will set this to 99%. I can also deep dive into the logs volume in Stackdriver monitoring using the Metrics Explorer tool and visualize exactly where my volume of logs is coming from. All right. And if we could cut back, please, to the presentation. Awesome.
Thanks. So now with a solution like Stackdriver, we can say that logging is not longer boring. But before that, handling logs in the different formats, many sources, and correlate data is quite hard. And I'm sure if you are working already with distributed system or cluster or with Kubernetes, there's quite challenges that needs to be solved. So what I'm going to explain now is about how logging operates at Kubernetes level. So if you understand the problem, how it works behind the scenes, means that you can optimize the engine queries and get better insights from your data. Do we have any Kubernetes users here? Oh, good. So I'm going to do like a little introduction about how logging works in Kubernetes or when you play with Docker containers. Basically, you have one application that triggers a message. And that message means to be like a log message saying a status, an alert, a warning, or anything related. For the example, we have like a next. But it's not just about the message. That message has some metadata that needs to be correlated. One of them is at what time this message was generated. And the other is what's the channel that this message was generated from. If we speak about containers, you know there are two main channels, standard output, standard error. And here, for example, ANEX is just not ANEX. We have a JSON example with metadata. And that message then needs to be stored somewhere. There are many ways to store container logs or in Kubernetes logs. For example, there is systemd, but here we are going to refer how Docker operate. Basically, your message is stored in the file system in a path, right? So every message becomes a new JSON map, and every message is appended at the end of that file. But things will become a little bit complex later. Because if we think about how Kubernetes works from an architecture perspective, we can think about this. You have your application, the most simple use case. That application is running in a container. Container appends limitation, restrictions, and allows you to set up certain policy rules, and also how this process that is running can communicate with others. And when I say a container, you know that container is just a concept, right? From an operating system perspective, it's all about namespaces and C groups. So your application runs in a container, and that container runs in a concept which is called a pod. So things get complex because a pod can have multiple containers. And multiple pods can be running on the same node. And a node I'm referring to a bare metal machine or a virtual machine. So here is just one single machine, right? But in a real cluster, you have many of them. So imagine that you have your distributed application. You tell Kubernetes, please deploy my application. Kubernetes, based on scheduling policies, is going to decide where these containers will run or will scale up. We're going to create some replicas on which node these replicas will run. Unlikely, not all of them will run in the same node. So these become complex. If I tell you 20 years ago, please look at the logs from my application, well, you open the terminal, you do some SSH, and look what's going on with your application. Just cut file, and you get the message. But on this, if you have a huge cluster, you cannot do SSH on every node and trying to find which is the Docker JSON file that belongs to the application that I just deployed, but maybe that application was destroyed because it failed or it was scaled up. So things become more complex. And complex because we need to create or try to gather some context. And what do I refer with context? Because your application is running in a pod. That pod has a name. That pod has an ID, an identification. Also, you're running in a namespace. If you deploy a pod, that pod belongs to a namespace. It's running in a node, in a host. And maybe you added some labels and annotation to that pod. Because maybe an annotation saying, no, for example, some labels saying, okay, status running or belongs to production, quality, testing, or anything like that. So how do you create all this context for an application which is running in Kubernetes? This whole context also appends more complexity. And it's because the container name and the container ID, you can find it in the file system. I'm talking here about the very low level how things operate, right? You can get that. But all of the other components comes from the Kubernetes API server or the master server. So you have some information that is locally in the node and other information that's in a separate machine. And you need that your login agent be able to get all of this information together. And that's why the login agent that you use and Stackdriver use needs to be able to handle all of this for you. Because, of course, you cannot do this manually. But your login agent needs to be able to query the file system, understand the messages, parse the messages, which are in different formats, and correlate all the information together with context coming from the API server. And that's Fluent D. Actually, Stackdriver uses Fluent D. You will find it as Google Fluent D, because it's a Fluent D packaged, ready to use with Google services, which has the whole extensions and integration with Stackdriver right out of the box. And once you get the things on Fluent D as a log processor, you can send things to Stackdriver or maybe your own database. Maybe you're running on-prem, or you have your own system to store logs. So that's why the login agents, it's not easy to be a login agent as a tool, and also needs to be able and communicate with different components over the network. Now, log processing in Kubernetes is like the next step. If we think that we have just a single node, well, we have the master and a single node, Fluent D, as a login agent, needs to run as a daemon set. Do you know what is a daemon set is? Are you familiar with pods? We just spoke about pods. OK. A daemon set, it's like a pod, but this pod runs on every node of the cluster. So if you append more nodes to your Kubernetes cluster, like a VM meta machine, and you already deployed a daemon set, you're going to get a new pod with that daemon set running on that new node. So the way to work is that you deploy Fluent as a daemon set. Of course, GKE is all already working functional by default. What it does, it's running, and it starts reading the whole log files that we explained a few slides ago, and all the content and JSON files that were created. Once it read the whole content from the application, it makes sure to gather the metadata that associate every message with every container, with every pod, with labels, annotations, and so on. So this simple message that we started at the beginning becomes something like this, with context. Because it has Kubernetes, it has a host, pod name, pod ID, container name, namespace, and so on. Because then, in a Stackdriver or any database that you're using, you don't want to query a show me the message that start with a next. You want to say, show me all the messages that, for example, that the container name, so Kubernetes, that container name equal next. So this metadata allows you to do a better data analysis and help the storage solution to query the data that you really care about it and not query all of them.
Thanks. So I mentioned earlier that we have the same team that supports both our cloud logging solution and Google's internal logging solution. So we've learned a lot of lessons talking to customers like yourselves and customers at Google who use the logging tools that we build. So I wanted to share some lessons learned. One is the value of structured logs. So not all logs are created equal. They all have great potential. But if we format them in a specific way, we're able to answer questions more easily. So an unstructured log might have a text payload of, blah, 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 purchased 4 widgets. A structured log will have a lot of key value pairs in JSON format. And this makes it much easier then to answer questions like how many unique customers purchased a widget? How many widgets were purchased overall? If you use structured logs, you can then send, when you, for example, send stuff to BigQuery, that structure will persist and make it much easier to interact with your logs downstream as well. Plus, you can do things in Stackdriver logging, like say, show me the customer ID hash. I want that to be displayed easily so I can understand what's going on more quickly. The other tip that we have learned over the years is that it can be really tricky to get the right level of logging. Right? If you do too much, it's crazy expensive and you can't find anything in your logs. If you do too little, then you don't have the data that you need when you need it. And so trying to get that just right level of logs can be a real challenge, both internal to Google and for our customers. There's no magic bullet here, but one thing we found to be really helpful is to enforce a consistent definition for logging levels through your code. So, an error should be something that really stopped your code, and you expect somebody to actually investigate here. Whereas maybe debug and info are less important. And that makes it easier when I filter to quickly find the information that we care about. And the final kind of insight we've derived over time is that it's really helpful to have data about the log volume so that you can iterate and refine this over time. So specifically, in Stackdriver logging, we have metrics at a very fine-grained level, so you can see not only which resources are sending logs, but which logs or which, are you getting mostly errors or are these mostly info statements? And you can slice and dice your data in all sorts of ways, which can allow you to iterate on your logging solution over time. Right.
Thank you. So getting back to logging agents, there are many solutions and open source projects available. But when talking about specifically about Fluent, which is a default agent stack driver and also for OpenShift from Red Hat and other companies and products, we can think that Fluent is more than just a simple open source project. I would like to say that it's a full ecosystem, since the moment there are many companies contributing back to the same project means that it's more relevant for the market, and also is becoming a huge solution. And at some point, people said that Fluent for some cases was too heavy, or we have some performance issues. And sometimes the answer is, not the answer, but the back question is, how many records are you ingesting per second? Sometimes they say a few thousands per second. Of course, you're going to have some performance penalties. You need memory, CPU, and you are filtering data, and you have like 10 filters. That is time consuming. And they said, okay, but we need something lightweight. Fluent originally is written in Ruby and C. It's quite performant, but at high scale, some companies and customers said we need something that can be lightweight and more tied to cloud native solutions. And that's why we created a second project, which is called Fluent Bit, created same by Treasure Data, now driven by the community. It's also with the Cloud Native Computing Foundation. And Fluent Bit tried to solve the problems in the cloud native space in a different way, using the same background or experience from Fluent. This is not like a replacement for Fluent, but most of cases, people said, I want to use Fluent, and for this special namespace cluster, I'm going to run Fluent Bit because of performance reason or special features. And the good thing about Fluent Bit is that it's written in pure ANSI C language. It's optimized for performance, low memory footprint, and it also has a pluggable architecture. It's pretty much a Fluent, but Fluent ecosystem is quite huge. We have 700 plugins. Here we have like 45. So you can see that it's more tied for specific things. And it's fully integrated with Kubernetes and Prometheus, and it's a sub-project of the CNCF. And like a kind of announcement, we are releasing in a couple of days the new version, which is called 0.14. I think that sometimes numbers does not mean something. The project has been around for more than 3 years. So, but we're trying to have the 1.0 at the end of the year. And 0.14 will have integration with Google Stack Driver. It will not, at the beginning, this integration is quite experimental. Means that it doesn't have the whole features that Google Fluent has, but we are working on that. Also, we will have the load balancing capabilities. In logging, there's one specific feature that if you are dispatching your logs to your service and you have some network outage, your logging agent needs to be able to recover from that situation, meaning doing buffering or maybe trying, if it failed from point A, try to do some balancing and try point B or a different node. So that balancing capability is coming up right now. And also, we're happy to say that we are implementing a new way to do filtering in a logging agent. If you wanted to do some filtering of Fluent, you had to write your own Ruby script for filtering. But if you wanted to do it on Fluent Bit, like a few weeks ago, you had to write your C filter. And for some people said, I cannot write C, it's too complex, and I don't have the time, which is right. And when we were in Europe at the beginning of this year in KubeCon, and some people say, hey, GDPR is coming. And I was not aware about GDPR. Okay, what is GDPR? Tell me more about it. And they said, okay, we need to obfuscate data. We need to add some conditionals for the configuration for Fluent Bit, and things like A, B, C, D. Okay, that is too complex. We cannot maintain multiple plugins for different needs. Yeah, because they said our logs are credit card transactions, and they have the whole numbers, and we need to obfuscate the data. So we need a solution, right? That is important. So we said, OK, a new way to do filtering will be, let's try to do some scripting. You run Fluent Bit as an agent, but also when it starts, you can start your own scripts, reading in Lua language, which are quite performant, and you can do all the data modifications that you want with a low performance penalty. And also, we have an address here. If you want to get more about all the news on Fluent Bit 0.14 to be released, there's a link on the slides that a form where you can sign up to get the news. And we're taking the Lua script. This is like a simple plugin. Well, this is like a text file. This is Lua. With basically, you create a new record using Lua tables, where you can put the old content in one index, the new content in a new key, and just return those values. And Fluent Bit will be able to understand that this modification was requested from Lua, and will modify your records for you, so you don't need to create a new filter for Fluent Bit and just write your own Lua scripts. So Fluent Bit is a quite exciting project. Actually, we get like, from a Docker and Kubernetes perspective, we get like $50,000 a day and growing, which is a lot. So we expect to reach a huge millions at the end of the year. And thank you.